All right, let's go over some trigonometric identities. Some identities that we are familiar with include the reciprocal identities. These identities include secant, I'm not going to use x, I'm going to use theta. Secant theta equals 1 over cosine theta. We know that cosecant theta is 1 over sine theta. We know that cotangent theta can be expressed as cosine theta over sine theta. And we also know that tangent can be expressed as sine over cosine. So these are the identities that we are already familiar with, but it's nice to be able to review them because now we're going to be able to go a little further into these. And what I'm going to introduce are what are called Pythagorean identities. So now, we've seen this word Pythagorean before, and it comes from the Pythagorean theorem, and that's where this comes from. So in order to introduce a Pythagorean identity, I'm going to go back to the unit circle. So let's draw the unit circle. And here we are. So now, we said that an angle of rotation on the unit circle can generate a right triangle. We said that this was an x distance, this was a y distance, and now we have a right triangle on the unit circle, so the hypotenuse is 1. Now, we know if this is our reference angle theta, then the cosine of that angle is equal to adjacent over hypotenuse. Well, the adjacent here is x, the hypotenuse here is 1, therefore cosine is x. This is just a review of the unit circle. Sine theta is equal to opposite over hypotenuse. Well, the opposite here is y, the hypotenuse is 1, and y over 1 is y. So not only can we express this as x, we can say that this is also cosine. Not only can we say this is y, we can say that this is also sine. So now, the Pythagorean identity comes from the fact that a squared plus b squared equals c squared. So there's a couple of things we could recognize from that. Getting rid of this, we can say that we have x squared plus y squared equals 1 squared, or x squared plus y squared equals 1. This is a topic that we've covered also. This is the equation of a circle centered on the origin with the radius of 1. So that's the equation of the unit circle. X minus a squared plus y minus b squared equals c squared, where a is 0, y is 0, so the center of the circle is 0, 0, and the radius is radical 1, 1. But we said that x is cosine. We said that y is sine. Equals 1. So this is the Pythagorean identity. Cosine squared plus sine squared equals 1. The most important one, this is where all of the other ones come from. So let's just remember the fact that cosine squared plus sine squared equals 1, and let's try to develop some other Pythagorean identities. So let's see. Pythagorean identities all come from sine squared plus cosine squared equals 1. They all come from that fact. That is an identity. So we can subtract sine squared from both sides and come up with another one. And say cosine is equal to 1 minus sine squared. Well, let's go back to the original and say, well, why can't I subtract cosine squared? You can. Sine squared is equal to 1 minus cosine squared. Okay, so here are two identities that came from this identity. just by subtracting either sine squared or cosine squared. So what this is saying is that cosine squared can be expressed as 1 minus sine squared, or 1 minus sine squared can be expressed as cosine squared. They are equivalent expressions. They can be substituted for one another. Let's take this original identity and let's divide everything by sine squared. So we're going to do this divided by sine squared, this divided by sine squared, and this divided by sine squared to come up with a new identity. Well, sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. Just really quick side note, notice the position of squared. When you're writing sine squared, make sure you're squaring the function value and not the angle. This does not mean sine squared. That's telling you that the angle is being squared. Very important to recognize that. So make sure you're squaring the function and not the angle. All right, so we can do the same thing over here, and we can subtract 1 from both sides and say cotangent squared is equal to cosecant squared minus 1, or we can subtract cotangent squared and say 1 equals cosecant squared minus cotangent squared. So that's another identity. Let's go back to the original identity. In order to yield this identity, what I did, I divided everything by sine squared. Let's divide all 3 terms by cosine squared now and come up with our third and final Pythagorean identity. So if we divide all 3 of these terms by cosine squared, well, sine squared over cosine squared, tangent squared. Cosine squared over cosine squared, 1. Again, I'm dividing by cosine squared. 1 divided by cosine squared, secant squared. So there's our third and final identity, in which we come up with 2 alternates by subtracting both tan squared and 1 from both sides. So if I subtract 1 from both sides, I can say that tan squared is equal to secant squared minus 1. Well, if I subtract 1 tan squared from both sides, I can say 1 equals secant squared minus tan squared. Okay, so it all boils down from this fact. If you remember that sine squared plus cosine squared equals 1, then you can either add or subtract to substitute for something, or you can divide all 3 terms by the same thing and then add or subtract. Now, it depends on what you're trying to substitute for. So you may be saying, where are we ever going to use this? Well, let's simplify the following. Let's say we had sine squared plus cosine squared all over sine squared. And our directions are to simplify this. Well, I know that sine squared plus cosine squared equals 1. And 1 over sine squared, I know, is cosecant squared. So these identities are just a nice way to clean things up. Let's say we went a different route. Let's say I didn't recognize the fact that sine squared plus cosine squared is 1, but I did recognize that I have a common denominator here. So let's divide both of these terms. Sine squared over sine squared, 1. And cosine squared over sine squared is cotangent squared. Then let's say you didn't recognize that was an identity. So you may be thinking to yourself, how can I clean this up? Well, let's try to yield an identity that contains cotangent squared. They all come from sine squared plus cosine squared equals 1. So now I want to yield an identity that contains cotangent squared. The way I can get cotangent squared, what would I have to divide by? You have to divide accordingly. I know that cotangent is cosine over sine. So I would have to divide by sine squared to yield a cotangent squared. So I'm going to divide all 3 of these terms by sine squared. Again, that's because I'm trying to yield a cotangent squared. Well, 1 plus cotangent squared is equal to cosecant squared. Well, 1 plus tan squared. 1 plus cotangent squared. 1 plus cotangent squared. What is it? It's cosecant squared. And there we go. Let's try another one. Let's say we had tan squared plus 1 over cosecant squared. And let's clean this up. So now, I didn't memorize any of these identities. I'm having trouble figuring out what tan squared plus 1 is equal to. Again, start with sine squared plus cosine squared equals 1. This is the only one you have to memorize. And we're trying to yield a tangent squared. If I want to yield the tangent squared, I have to divide accordingly. So sine squared over cosine squared. So let's divide all of these three terms by cosine squared individually. Sine squared over cosine squared, tangent squared. Cosine squared over cosine squared, 1. And 1 over cosine squared, secant squared. So now I know that tan squared plus 1 is secant squared. So I can say that this is secant squared over cosecant squared. Now let's express these functions in terms of sine and cosine. I know that secant squared is 1 over cosine squared over, and I know that cosecant squared is 1 over sine squared. So now after we keep, change, flip, you end up with sine squared over cosine squared, which is tangent squared. So now what identities do, they just make life a little bit easier on you. Let me do one more example in which you will not have to use a Pythagorean identity. Let's say we had something like secant theta over cosecant theta. Now the reason we're not using a Pythagorean identity, the word Pythagorean, a squared plus b squared equals c squared. You have to be squared to use a Pythagorean identity, so I cannot substitute using Pythagorean identities here. These are simply reciprocal identities. So secant, 1 over cosine, cosecant, 1 over sine, keep, change, flip, and you end up with sine over cosine, which is tangent. Okay, so the story here is that you're not always using Pythagorean identities. Only for terms that are being squared can you use Pythagorean identities.